We can paint the world a beautiful picture, hold it up for everyone to view.
So, as you can see, functions take many, many different shapes, and this is not by any means an extensive, exclusive, contained list of what functions look like. Functions are as diverse as many of the equations they come from. So what are we going to be looking at? Well, this is the tangent function. I don't think we're going to be doing that anytime soon. And this is a piecewise function. You'll do this in Algebra 2. And we will be doing parabolas, extensive use of parabolas. We will be doing absolute value functions. This is a step function. We'll be doing that. You'll be doing that in Algebra 2. We can look at those. I think we look at those a little tiny bit. And this is exponential growth, so we will be doing that. So let's start taking a look at how we can have a table of values that might relate to a graph. So when we try to write a function from a table, writing a function from a table is kind of like an f of x equals something, but we typically write it as y equals something so that we can graph it on an xy axis. You will, however, in high school sometimes see this labeled as f of x and this labeled as x. Okay? All right, so different situations that you're going to have. You're going to have curves or you're going to have lines, basically. When you have situation 1 where the product of x and y are a constant, so you might have like xy equals 16, for instance, that is nonlinear. That is a hyperbola. And in that case, it's going to look something like this. You will be doing different hyperbolas in high school that may look something like this. Okay, but their equations are different than xy equals 16. In any case, exponents are involved. So if exponents are involved, it is definitely nonlinear. It is not a line. And it might be a parabola. It might be an ellipse. Okay, parabolas, we're going to do an extensive use of parabolas coming forward. And if x and y change in constant amounts, you're going to get a line. So that's going to look like y equals mx plus b. You will become very, very familiar with that form. Right now it looks kind of weird, but it's actually very commonly used in math. So how do we find what this graph looks like? We are going to write the equations of the various graphs based upon their tables. Okay? Now this process is going to look a little confusing to you until I actually map it out for you. So I'm going to go forward and show you what I do before I talk about this, because if I talk about it, it's going to go in one ear and out the other. You're not going to really have anywhere to sort that in your brain. All right, so we take a table, and we know these are various points on our graph. So for instance, the 0.26 is somewhere on the graph. The 0.39 is on the graph, okay? And you can always use a table to try to see what's going on in your graph. It's a very useful strategy. So the first thing it tells us to do is find the change in y. And when I say change, I'm going to use delta, the Greek letter delta, for change. And you will see that used in math and in science. So the change is 3, the change is 3, and the change is 3. Then it says to find the change in x. So the change is 1, the change is 1, and the change is 1. Then it says to find the ratio of the change in y to the change in x. So that's 3 to 1 in all cases. So my delta y over delta x is the ratio, okay? This is going to be your m. This is my m, part of the equation of the line. So y equals mx plus b. That's my m. So my question to you is, does y equal 3x in this case? And if you look at it, well, 3 times 2 is 6, 3 times 3 is 9, 4 times 3, 12, and 5 times 3, 15. So this, in fact, is the equation of the function described by that table. That's not usually going to be the case. All right, so let's take our baby steps and go forward. So what are the changes here? In every case, the change is 2. And it's not always going to be the same, so you have to look. In every case here, the change is 1. So my delta y over delta x, my change in y over my change in x, that ratio is 2 over 1 for all of them. So therefore, that's my little 3 dots that I've used in the past, I think I told you about. Therefore, m equals 2. And my question is, does y equal 2x? Well, 0 times 2 is 2. 1 times 2, 2, 2 times 2, 4, and 3 times 2, 6. No, that is not what y equals, as a matter of fact. Then you have to find the b. Okay? Can I add something to each of these values here? Let me get a little highlighter here. Can I add something to each of those to end up with my y? Well, your answer should be yes. In every case, I can add 1. Or no, not 1. What did I do here? Oh, silly me. 0 times 2 is 0. Hope you guys corrected me on that. Okay, I can add 3. Okay, so my b is going to be 3. All right, so this is now the equation of that function described by the table, which happens to be a line. Moving on, let's do 3. I want you guys to come up with your delta y over delta x. You can pause here if you need to. All of these changes, I'm going to stay in blue, are 1. And all of my x changes are negative 1. Makes a difference. So my slope, which is delta y over delta x, equals negative 1. Okay? Is y equal to negative x? Your answer should be absolutely not. So what do we need to add or subtract? In each case, you have to make sure it works for every line of the table to get the correct answer. Well, you would have to add 2. Okay? Try the next one. You can pause the video here and try it on your own, okay? Alrighty, so I got my delta y over delta x to be 3 over 1, or 3. So that's my slope. So I say, does y equal 3x? It does not. So is there something I can add or subtract to give me my y that I want? Well, this would be a 0, this would be a 3, this would be a 6, and this would be a 9. So if I subtract 2 in each of those cases, it would give me the correct equation of the line that would work for all cases. Let's go on the back. Delta y. Delta y, whoops, where's my back? There's my back. Delta y here is going to be 16. Is it 16 in the next case? No, it is not. Does that mean it's not a function or not a line? No, it does not. We have lots of different functions, and we have different ways of getting our line. And I will show you that in a second. Now, in all these cases, I'm going up by 2. So my ratio is not constant. So this is not a constant ratio. Is there another pattern to the table? Okay, that's what you look for next. If it's not a constant ratio, then is there another pattern? You should be noticing another pattern, and that is, hopefully you got it, ERN, I could spell, okay, that actually y equals x squared. Hopefully most of you got that by looking at the table. That is a parabola, the most basic parabola. Okay? All right, how about the next one? In this case, all of my changes here are adding 2. All of my changes here are adding 4. So my ratio, remember, is delta y over delta x, which is 2 over 4, or 1/2. So does y equal 1/2 x? Well, that would be a 6, an 8, a 10, and a 12. No, it doesn't. What do I need to add or subtract to each line? A 2. Okay? So this is actually another linear equation. Take a look at the next one and tell me what you think. This change is negative 12. This change is negative 4. This change is negative 2. And all of these are plus 1, not a constant ratio. Okay? So we're looking for another pattern. Do you see it? And you will get used to looking for these. Certain things come up again and again. So hopefully you'll get used to that. All right, so the pattern in this case is x, y equals 24. And if you didn't see it, you will learn to look for that pattern. This is my hyperbola. Now the next one's going to look very interesting to you, so go ahead and see what you think about that. I'm looking at these and I'm saying no pattern at all, bummer. What could this possibly be? Well, when I told you to look for a ratio, I meant you look for the ratio 1 by 1. So this ratio is 9 over 3, which is 3. Okay? This ratio is negative 6 over negative 2, which is 3. And this ratio is negative 9 over negative 3, which is also 3. So it's the ratio, guys. It's the ratio we're concerned with. It's not the numbers here. Okay, I'm concerned about the ratio. And in this case, the ratio is constant. It is 3. So that's my m. Okay, so does y equal 3x? Is there something you can add or subtract to get it to the correct y? And I would say yes, it's minus 2. All right, so I would like, in addition to your notes, I would like some questions. You should have lots of questions here. Okay, maybe you could try and create a table that someone might have to write a line or a hyperbola or a parabola for. And you should think about questions that you might have. In addition, I think there might be a couple problems that I gave you in the packet that you could work on. But you want to be sure that you understand everything in this video, so if you need to watch it again and read your notes over carefully, then maybe that's a good strategy too. Have a wonderful night. I will see you in the morning.